What if I told you a robot just learned how to remember the real world like a human, not just see it, not just map it, but actually build a searchable memory of everything happening around it? Sounds like science fiction, but a new framework called OpenClaw might have just pushed robotics into a completely new era. And here's the crazy part. At first glance, the clip that started circulating online looked like just another robotics demo. A humanoid robot slowly walking through a room, scanning its surroundings using LiDAR and cameras. Engineers have seen that kind of thing thousands of times before. Robots scanning environments is nothing new. They build maps, avoid obstacles, and navigate rooms all the time, but something very different was happening behind the scenes. Instead of simply mapping the room for navigation, the robot was doing something much more powerful. It was building a memory of the world. Not a video recording. Not a temporary map. An actual structured memory system linking space, objects, and time together. And that single change made a lot of robotics engineers stop and pay attention, because this robot wasn't just reacting to what it saw in the moment anymore. It was starting to remember its experiences. To understand why this is such a big deal, we need to look at how robots normally work. Traditional robots live almost entirely in the present moment. They read sensor data, update their map, and react to what they see. If something changes in the room, the robot adjusts its map and moves accordingly. But the context of what happened earlier, that usually disappears very quickly. A robot might know where a chair is right now, but it typically doesn't remember when the chair was moved, who moved it, or how the room looked yesterday. This new system changes that. Using OpenClaw, the robot can link three critical elements together: where something happened and what object or person was involved when the event occurred. That means every movement, every object, and every interaction becomes part of a timeline of the physical world. Now here's where things get even more interesting. Instead of storing raw images or endless video recordings, the system converts the environment into something called voxels. Imagine dividing physical space into thousands of tiny cubes like 3D pixels. Each cube stores information about the world inside it. Geometry, object identity, location, timestamp. Over time, the robot builds a layered 3D memory structure containing rooms, objects, surfaces, people, and events. This is what researchers call spatial agent memory, and the implications are huge, because once a robot has this kind of structured memory, you can start asking questions about the past. For example, where were the keys last seen? Who entered the house yesterday evening? Which room do people spend the most time in? Instead of replaying security footage like a camera system, the robot simply queries its spatial memory. And within seconds, it can return the answer. That's the moment when the technology starts to feel very different, because a robot that understands the connection between space, objects, and time isn't just navigating anymore. It's building knowledge about the world, and that's why the clip exploded online. Some researchers called it a major milestone for embodied AI. Others joked that someone had basically open-sourced Skynet on GitHub. Of course, that comparison is exaggerated, but the reaction reveals something important. For decades, robotics has struggled with one major limitation: robots could see the world, but they couldn't remember it properly. Now that barrier might finally be breaking. But here's the twist most people completely missed. OpenClaw wasn't originally designed for robots at all. It started as an AI agent framework. Its original purpose was to give large language models the ability to perform real actions instead of just generating text. Think about what that means. Instead of answering questions, AI systems could run software tools, execute commands, automate workflows, interact with APIs. Control applications. Developers often describe this as giving AI systems hands, and now those hands are starting to control physical machines. That's why the robotics community suddenly became interested, because if AI agents already know how to plan actions, call tools, and execute tasks, connecting them to robots suddenly becomes much easier. In the demonstration that sparked the discussion, The robot's sensors continuously fed spatial data into the OpenClaw system. On top of that, developers added something called Spatial RAG, a method for retrieving information from the robot's environmental memory. Together, these layers allow the robot to organize enormous streams of real-world data, and that data grows incredibly fast every second a robot collects. Video frames, depth maps, 3D point clouds, motion data, object detection signals over time. That turns into hundreds of hours of environmental information. Turning that chaos into something meaningful has always been one of robotics' hardest problems. OpenClaw is one of the first frameworks trying to solve it in a scalable way, of course. The internet immediately started questioning whether the system would actually work in the real world. Some engineers argued that adding language models might slow everything down, but the developers designed the architecture differently. The robot's motion control system still handles real-time movement at high speed. Motors, joints, and locomotion operate independently. OpenClaw sits above that layer, acting as a coordination system. It observes the environment, manages memory, and decides which actions should happen next. This separation allows robots to move quickly while still developing long-term understanding of their surroundings. And once that layer exists, the possibilities expand very quickly. Developers have already connected OpenClaw to multiple machines. A humanoid robot called Unitree G1 can be controlled through simple text messages instead of writing complex robotics code. Users can send commands like move forward 1 meter, turn left 45 degrees, capture a photo. The robot receives the message and executes the action. Other experiments connected the framework to robotic arms and AI-controlled hands. In one test, a robotic hand learned gestures like a fist and a peace sign while narrating its actions through Telegram messages. And at an even larger scale, robotics platforms are starting to integrate OpenClaw into industrial automation systems. Entire fleets of robots could eventually share skills with each other. One robot learns something, the knowledge spreads across the network, and suddenly every robot becomes more capable. So what does all of this mean? We might be witnessing the early stages of something much bigger. For years, AI systems lived entirely inside computers. They processed text, images, and data, but they had no direct connection to the physical world. Now, that's changing. AI agents are starting to see reality, interact with it, and remember it. And once machines gain persistent memory of the environments they operate in, the line between software intelligence and physical action begins to disappear, which raises a fascinating question. If robots can now remember the world they move through, what happens when millions of them start sharing that knowledge? Because the moment machines begin learning from real-world experience at scale, robotics could accelerate faster than anything we've seen before. And this OpenClaw demo might be one of the first glimpses of that future.